NEC Section 210.19a on and 3 addresses conductor ampacity and sizing, providing guidance on selecting the appropriate conductor size for branch circuits. Specifically, 210.19a states that branch circuits rated for 15 or 20 amps must have a conductor ampacity not less than the maximum load they serve. This means the wire size must be adequate to handle the continuous and non-continuous loads without exceeding its temperature rating. The overcurrent protective device, or OCPD, such as a circuit breaker or fuse, is intended to protect the conductor from overloads and short circuits. However, the conductor itself must be sized to carry the intended load. NEC Section 210.19a addresses conductors for general lighting, stipulating that they must have an ampacity that is at least that required by Section 220.10b exception. This exception likely refers to specific circumstances or types of lighting loads where a reduced ampacity might be permissible under certain conditions. Feeder conductors supplying lighting loads must have an ampacity at least that required by Section 215.2a on exception number 1. Feeders are larger conductors that supply power to multiple branch circuits. The exception referenced here may allow for a reduction in feeder size based on factors such as load diversity or demand factors. Now let's analyze the scenario where a sign question has a calculated load of 1800 volt amps multiplied by 125%, resulting in 2250 volt amps. Dividing this by 120 volts gives a current of 18.8 amps. The question suggests that a 20 amp OCPD is being used, even though it's acknowledged that a 20 amp OCPD is often considered to have a maximum continuous load of 80% of its rating, which would be 16 amps. The key here is understanding the application of the 125% rule. For continuous loads, which are loads expected to operate for 3 IOs or more, the NEC requires that the OCPD and conductors be rated at 125% of the continuous load. This 125% factor is already incorporated into the 18.8 amps calculation, as it started with 1800 volt amps and was multiplied by 125%. Therefore, the 18.8 amps already reflects the increased current demand for a continuous load. Given that the calculated continuous load including the 125% factor is 18.8 amps, a 20 amp OCPD is permissible because it's greater than the calculated continuous load. The 80% rating rule, where an OCPD should not be loaded to more than 80% of its rating for continuous loads, is often misunderstood. In this case, the 125% factor applied to the load already accounts for the need to avoid overloading the OCPD. In other words, the 18.8 amps figure is the adjusted load that already incorporates the 125% multiplier. The conductor ampacity must also be considered. The conductor needs to be sized to handle at least 18.8 amps. The specific wire gauge required depends on the conductor's insulation type, the ambient temperature, and other dating factors. The NEC provides ampacity tables, such as Table 310.15b16, that list the allowable ampacities of various conductors based on their size and insulation type. It's important to consult these tables and apply any necessary correction or dating factors. In summary, NEC sections 210.19a on and 3 allow the use of a 20 amp OCPD for an 18.8 amp continuous load in this scenario because the load calculation already includes the 125% factor for continuous loads. The conductor must be sized to handle the 18.8 amps, taking into account any applicable dating factors. Always consult the latest edition of the NEC and local codes for specific requirements and ensure compliance with all applicable regulations.